Okay, in this video we will continue on the beginner's guide to SDL2 in C++. So if you're just starting out with this video, you'll need to clone the GitHub repository at github.com, Programming Rainbow, Beginner's Guide to SDL2 in CPP. And since this is the fifth video, you can take the code from where we ended off in the fourth video, the code right in here, and you can copy that up into the source directory and we can use that. Okay, I will just show you where we left off in the last video. So here's compiling it, and here's playing it. We have a background image, and we can press spacebar, and we get a random color in the background. And it says background up here. It should say changing colors. We didn't change that last video. So here, where it says background, we could have made that changing colors. And we should see changing colors up there now. Okay. Like I said, it's been a while since I did any C++ programming, and I didn't realize that this is implicit a lot of times, but sometimes it can be ambiguous, so that's why this isn't used in Gen. We should have just put this there, just to be explicit about what we're doing. Going to compile it one last time, and then we're going to get into this video is what we're doing. Okay, we still have random colors. We're good to go. So in this video, what we want to do is we want to make text that we're going to move it around the screen in the next video. But in this video, we just want to be able to make text as an image of the font type that we want. We want it to say what we want. We want to display it in the game. So we have to do quite a sequence of events here to make all this happen. So for one, we're going to be using a new module like we did with the image module, where we're using the TTF module. I'm just going to walk through what we're going to do real quick. We're going to initialize TTF, and then we're going to quit TTF. We will be opening a font, and we can close the font. So that's going to be a smart pointer right there. And then we can now render a text onto a surface with that font and a color that we will talk about as well. And that's going to be on a surface. So we have the color. We'll talk about the color there probably at the same time. And then we also can talk about the surface and how it has a width and a height, because we do need a rect. This time we are not going to be stretching our image to cover the whole screen. Instead, we're going to display it in its correct size. So we're going to be using an SDL rect. And then we want to convert this thing to a texture. So we're not using a surface, but we're using a texture. And then at that point, we can display it. So it's quite a sequence of events. The very first thing we need to do is initialize the TTF module. And this one's very easy. We don't need any flags. And we're just returning 0 on success. So we can just wrap this in an if statement, and we're done with that. And the quitting is very simple. It's a void function, and there is no arguments. So we're going to go to where we're initializing our modules. It's not in the game. It's in the right here in initialize SDL. So we've initialized SDL, we've initialized the image module, and now we will initialize the TTF module. And before we do that, sorry, we need to add in the header file for it. So this will be SDL2, SDL TTF.h. Okay, so that will pull in the header file. You do need to have the SDL TTF module already installed in your system. And now down here in initialize, we will just wrap it in an if statement because it's simple 0 on success. So if it's 0, it carries on. If it's other than 0, we're going to handle the error. So we have TTF init, and we're not passing anything in there. And then we're just checking the if it errored or not. So I'm just going to grab this error message up here. I'm going to yank that. I'm going to put it in, paste it. Okay, so this one we will say initializing SDL.TTF. And we're going to use TTF get error. Again, I believe under the hood this is simply a pointer to the actual SDL get error function, but just to be as correct as we can be, we're going to follow since this is a TTF function being called, we're going to get the error from TTF get error. And that is generating our error and throwing it. Now, since this is the first, second, and third thing we've initialized, it's going to be the first thing that we remove. So we're last in, first out. So TTF quit. And that's going to handle our initialization and our closing down of the TTF module. So I'm going to compile that real quick just to make sure we don't get any errors. And when we compile this, we will need to add in the new linker for this, the SDL2 TTF. So we will be adding that in. And we're just looking for no error. We do know that initialize SDL function is being called. We know that because from past videos, and we do know the closing down is being called. So we don't have to worry that we didn't call it. We already know that those functions are being called. Okay, so moving on from here, we've initialized TTF, so now we can make use of these functions. So we have a couple things here. Before we can make text onto a surface, we have to actually have a font. So we're going to be using TrueType font. So we need two things here. We're gonna need the destination of the font file that we're using, and I'll show you that in a minute. And then we're going to need a point size to our font. Point size, so as an integer, we're going to have the file, and this is going to return a heap allocated TrueType font object. So since this is heap allocated, it has a deconstructor, which is TTF close font, and it takes in the font and closes it. It's kind of like the SDL destroy window, SDL destroy texture, SDL destroy render. It's like that, except this one's called TTF close font. So since this is a pointer, this is going to be a unique pointer, and the memory cleaner is going to be wrapped in that same smart pointer. So let's create that right now. So I'm going to just add it below. Okay, and the type of this pointer is TTF font. And the type of the deleter is we need to declare type for the function pointer. And this is TTF close font. Okay, and we will just call this font. So this will be our font. So this is going to handle cleaning up of the font. We do need to initialize this. So we're going to initialize it to null right here. Null pointer. And we need to put in our deleter, which is the TTF close font. Okay. I spelled this wrong. Type. Okay, so that is our unique pointer. We do need some other things in here. So we have our unique pointer. We're not populating the pointer yet. Here we're just initializing it to null. And so I'm going to put the population of this font pointer in this kind of load media. I'm going to put it in this section. So we'll do this font reset. And the function call that we're going to use to create this font is this TTF open font. And we need the path to the file, or the file with the path, and we need a point size. Let's hold the point size in a, let's hold this in a variable, and we'll just put the path in directly. So I'm just going to say int font size. So this is called a font. So this other thing is related to the font that we're, the font size is related. So I'm just going to call it font size. So this will be an int size. And we can just initialize this. I guess it will be before the pointers. Be right here. And we'll initialize this to 80. That should work there. I guess we probably need the comma after it. Okay, so we're initializing that to 80. The load media, where did load media go? Here we are with the load media. So what goes in here is the TTF open font. And the first thing that we need is the actual path to the font that we're going to use. So the path is right here. In fonts folder, we have free sans bold.ttf. And this is the actual TrueType font file that we're going to use. And this is relative path. So I'm just going to put it fonts free, because we are working in the top level directory. That's where we're calling this binary from. The binary demo is in this top level. So our relative path is fonts. Free sans bold.ttf. And the other thing that we need is the font size. Okay, so we're calling that, and then we need to check to make sure that this did not return a null pointer. The failure of this function right here, on failure, it's going to return a null pointer. All of these SDL heap allocated functions, anytime they're allocating anything on the heap, if they fail, they just return a null pointer. So that's how you check to see if any of these SDL functions fail. So just like the one above, I'm just going to grab that, repurpose it down here. Need to change this to font. And we have, what should we give the error message? We'll say error creating font. And then I'm going to use the TTF get error here, because it's a TTF function call. Okay, so that gives us our font, and it already has the deleter in it, the TTF close font. So we don't need to worry about freeing that up. I just want to compile this to make sure I haven't made any errors yet. Okay, that still looks good. So we have this access to a font now. So to be able to make a text, let's get rid of these font and the close font. So we have this TTF render text blend. So the render text means that we're going to create some text and it's going to return a surface, an SDL surface. So we're going to get text on a surface, but specifically the blend version allows it to have aliasing, so it doesn't have kind of jagged corners or anything. So no matter what size you make the font, it's going to make it nice and smooth curves on it, on the text and stuff. No jagged edges, no aliasing. So that's the blend version. There is other ones besides blend, I think. Okay, so what we need here is we need the font, we need some kind of text, and we need the color. Okay, so since the text, we can extract this out into a member variable, and also the color. So we need to talk about colors. So an SDL color is just a a struct that has 4 uint8s in there. Just 4 numbers between 0 and 255, and it's a RGB alpha. So that's a SDL color. And I think we're just using white here, so that will be all 255s. Okay, so we'll make a font color, and we'll make a what should we call the text variable? We just call it font text, I guess. So up here, we're going to have this new, I'll call it text string. How about that? So we need this text. We'll go font color is an SDL color. So we have a font color, and then we are going to have a text string, which will be std. I don't have this in my notes. I just put the text straight into it, but maybe we should pull it out into a member variable. So I'll call this text, not text stir. And we will also need, and we'll talk about it. Well, I'll do it when we talk about it. So so we have this color and we have this string. So where's the font size? In our constructor here, we have the font size. Down here, well, I'm just going to assume it's going to format it for me. I want to put the font color, which is going to be just 255s. And this is going to be white. So if you don't want white, you want it to be another color. Remember, this is the red channel, this is the green channel, this is the blue channel. And these all 000 is black, and 255, 255, 255 is white. So you can pick a color between a number between 0 and 255 for each of these channels, and it'll go from a dark color to the brightest color of that of R, G, or B, and you can mix them up however you want and get the color they want. But you do want to have this one set to 255 because we do not want our text to be see-through. So this alpha channel is set to 255. Okay, so that gives us the color and the text. That is our text stir, and we will set that to SDL. Okay, I'm just going to save it. I'm just confused why this is here. It shouldn't be an error here. It should be an error down here somewhere. I'm just going to comment this out. These are, oh, okay, I put a colon here. Let's have a semicolon. Here we go. Okay, so I want to save this so that my auto formatter formats this, moves this around. There we go. It moved it in for me. I didn't want to mess around with tabs, and then it was going to fix it for me anyway. So we have the color, we have the text. So down here, back into the load media, we want to create our surface. Oh, so we don't have a surface yet, actually. I didn't even think of that one. So normally in C, what I would have done is I would have made a temporary pointer for the surface, and I would have created the surface, converted the surface to a texture, and then freed that surface, and the surface pointer would go out of scope. But since I'm using smart pointers here, unique pointers, and a little bit, because I'm a little bit lazy here on this, what I'm going to do is I'm going to create the surface pointer right here and just let it exist and handle and clean up itself and not worry about any of that. But that's how I would have done it in C. But in C++, because we got these unique pointers, I'm just going to let the surface exist. Even know that we're converting the surface to a texture later, I'm just going to let the smart pointer handle the surface for me and not really worry too much about it. So I do have surface open here somewhere. Yeah. So we're going to be capturing this when we convert this, when we create this texture, we need a surface. So we need the pointer that's going to be held, we need a smart pointer for the surface. So the type surface is here, and we're going to talk about it later. It's got a width and a height that we can use on it. The way that we free the memory of a surface is actually SDL free surface. So we need a smart pointer that is of type surface and also has this, and we pass the surface in to free it, and it's SDL free surface. So let's create that pointer. So this is, again, a unique pointer. And again, we could have made a local pointer and done that and freed the surface. But since we're just using unique pointers, I'm just going to continue with the way I'm already doing things. Okay, so this is of type SDL surface. And the deleter for this is the SDL free surface. So we need to get the declared type from that. I spelled type wrong again. And this is the function pointer. And I'm going to call this text surf, because this isn't the end product of what I want is a texture, and it's a text on a texture, so I'm just calling it text. But this is the middle point where I need the surface before I turn it into a texture, so I'm going to call this text surf. It's a surface that has my text on it. Okay, so that's a unique pointer to a surface, and we need to initialize this to null. So we'll say text surf, and it will be null pointer, and we need the deleter, which is the SDL free surface. Okay, so we have a pointer, and we're letting it free itself. So what we want to do is we want to use this function. Where is it? This render text blend. This is returning the surface, so that's what our pointer was for. So we're going to do a reset on that text surf pointer, and we're going to use this function right here. So this TTF render text blended. We need the font that we created earlier. We need the text, and we need the color. And we have all of those already. So let's just grab this function right here. And we're going to do a reset on this text surf reset and the function call that we're using. And we needed to pass in the font, the text, and the color. So this font. Now we need to unwrap the smart pointer here. So we'll use get. There's our font. And then our text is going to be this text string. But we need a C style string. So we need to call this C stir function on it. So this is going to take the SDL standard library string and turn it into a C style string for us. And then we need the color. So it's going to be this. What was it? Font color? Yeah, that's the one. So that is our function that's resetting the pointer to, and now we also need to check if this failed. And the way we check if it failed, again, is because it's going to return a null pointer if it errors. Okay, so we're basically checking if this is still null after we've called this. So I'm going to yank that up there. And this one is the text surf. So text surf error. So say error loading text surface. And this one is still a TTF because we are still calling a TTF function. So this is going to load our surface now. Okay. So we are going to be using a rectangle. So if we don't use a rectangle, if you remember in the past, we have a source rectangle when we're down here drawing. We have a source rectangle, which would be here, and we have a destination rectangle here. Now the problem with this, what we did with the original one is they're actually just the same size. The background image and our game screen are the exact same size. But the text we're creating is going to be far smaller. It's of point size 80, and it's just 3 letters SDL, so it's not going to be very big. Now, if we don't use a rectangle for this, we are going to end up with the image being stretched, and I will show that, what it looks like. But what we really want to do is we want to get the size of this text surface that we've created, and we want to populate a rectangle with that size, that width, and that height. And then what we can do is we can still use null pointer to grab the entire source of our text surface, or it will be texture. It will be a texture. But we want to use a rectangle to draw it on the render so it doesn't stretch the entire game screen. It actually displays as the proper. So imagine this SDL texture that we're creating is, say, 100 by 80. So let's say it's 100 pixels wide by 80 pixels tall, okay? So if it is like that, when we go to display it, it's going to stretch that 100 pixels wide to 800 pixels wide, and it's going to stretch our 80 pixels tall to 600 pixels tall. But what we can do is we can say, yes, we do want the whole source, but our destination rectangle, if we were to capture the width as 100 and our height as 80, and we put it into a rectangle, and then we say we have the X and Y set to 0, 0, we will display it on our screen at 0, 0 up here in the top left-hand corner, and then the width being displayed on the screen will be 100, and the height will be 80. It'll be the correct width and height, and that's what a rectangle does. Let me get to the rectangle. So all a rect is just a struct, and it's a C struct that has 4 ints in it. Sorry, 32-bit ints. So it's got an X, it's got a Y, which is your top left-hand corner of your image. It'd be like, say this is the image right here. The top left-hand corner would be right here. And that's going to be your X and Y. And then it has a width and a height. And we basically need to populate the width and the height, and then we can change the X and the Y to move it around the screen. And that's all it is. It's just 4 numbers in a struct. And so we need to populate that. We can do that off of the surface. But yeah, let's just get to where we're going with where were we at in the code? We'll be using null pointer for the source, but we will be using a rect for the destination. So the thing is since we have this surface that we've returned, where is it? So this is returning a surface, and the one thing that this surface has right here, this surface already has a width and height as members of this surface. So the surface is that heap allocated struct, and it already has 2 members that we can just access directly called width and height. So we can create our own rectangle, and we can immediately populate it with width and height directly from the surface without any headache. So that's what we're going to do. We'll create a rect, and then we'll populate its width and height members with the surface's width and height members. Okay, so I'm going to go up here, and I'm going to say it's SDL rect, is the type, and we'll call this text rect. So we could put it in here. I'm just going to put it in here and zero it out. So where is it? It's after the string. So here's the string, and I'm going to say text rect, and I'm just going to initialize it to zeros. As far as I know, if I just put 1 0, it's going to initialize all of them, all 4 to zeros, but you could do each one too. You could do this. But I think you just literally need the first one. I'm pretty sure in C++ you just can put a single 0 in there and it'll initialize all of them. So they're just going to be initialized to 0, just in case they weren't. And what we're going to do is down here where we have this surface, we're going to populate our text rect with the surface's text rect, which was the member dot width, and this is going to be equal to this text surf dot width, and we can do the same for height. Okay, so that populates our width and our height, and our x and y's are set to 0. So this should display in the top left-hand corner. So that's getting that. Now we could display this surface, but I don't want to. I think it's blit. I'm not even sure how to. I don't ever display surfaces. I want to convert this to a texture. So now from the texture, we have to call a more complicated function to get width and height. So I'm just grabbing it. Since I have a surface right now, I'm grabbing that because it's the easiest thing to do right here. And then right away, we want to convert this to a texture so we can display it. Okay, the way we do that, create texture from surface. So this one is a function that's returning an SDL texture. So we're going to need a new unique pointer, but we already know what a texture looks like. We've done that before. And this one we're taking in the render, and then we're taking in the surface. And it's just turning this surface into a texture. That's all it's doing. So let's make the unique pointer for this. And again, we've already done something very similar to this. The background is already a texture right here. So I'm just going to grab this one. Looks like we're missing something down here. Right here, we'll just put that. Whoops, come on now. That's not what I want. There we go. Okay, so, and this one is going to be called text. This is our actual text texture. Okay, I just want to look to see what I messed up down here somewhere. Constructor for game must explicitly text. Okay, yeah, I know that. We're already doing that. I think I'm missing something here. Yes, the comma. Okay, so right here we need to initialize that new text to null. So this is going to be null pointer, and we have the deleter for texture is SDL destroy texture. Okay. What did I did? Oh, why is this a render? I thought I got the background one. Oh, I must have grabbed the render one. That's confusing. And this is going to be destroy texture. I copied, instead of background, I copied render. Okay, there we go. So this should be a texture, SDL texture, and this should be SDL destroy texture, and this is a text. We're initializing it to a null pointer. Let's see if we don't have any errors now. So we have that pointer, so we need to call that function that converts this. This right here needs to be an arrow, not a member dot. Sorry, I was muted. These up here were I just changed these. These are need to be dereferenced to the width and the height for the surface. So you'll need to change that if you had the dot there. And this here is going to be the resetting of the text pointer like we've been doing up above. Because it's already set to null, we're resetting it. Okay, so the function call we need is this one. And this is taking a render, I believe, a render and a surface. So it's going to be this render, and we need to unwrap it. And then we have the surface, which is this text surf, and we need to unwrap that. And we'll put a semicolon, and this should populate or reset our smart pointer that populates it with the actual heap allocation. Okay, but we also need to check to see if this failed. If it failed, it's returning a null pointer, so we need to check for that as well. Okay, so this one is text. And this is creating texture from surface. Creating texture from surface. And this is going to be an SDL error. Okay, I'm just checking above here. This was the TTF error. That's good. Okay, so now we have a texture, finally, that we can display. So we can go down here to right here. And this happens back to front. So the first thing we have is our cleared render, and then drawn on top of that is the background image. Now drawn on top of that, we want to actually draw our text. So I'm gonna, since it's the same function as here, I'm gonna copy this. Okay, and it's still render copy, and we're still getting the render, but the image we want is text. Okay, not test, text. So text, and we still want the entire source, so we're going to be using the null pointer, but now we are going to use the rectangle for our destination. And actually, let me just show you what it looks like if I were to not do this. Okay, so hopefully we will see, it's going to be stretched and a bit ugly because it's a small text that we made that we're stretching it big. Now, if we made a big text, it would look really nice. But because we made a small text, you're going to see it like pixelated. That's not the fault of the TrueType font. That's the fault that I rendered it in a smaller and then blew it up. So you can make bigger text that is not pixelated, but this is what we're going to see. We're going to see pixelated, a bit stretched and ugly looking. Okay. So again, this is not the fault of the TrueType font. This is because it should be a small text here. Okay. So what we're going to do is we're going to use our rectangle. So it's this text rect. Okay. Now the problem with this is we need the address of this. Okay. So we're going to use the rectangle so that it, instead of stretching it to the entire screen, it just displays it with the width and the height that we got from the surface before we converted it to the texture. Okay, there we go. That's how it's supposed to look. Now, if we were to make the font size larger, it wouldn't be pixelated. It would draw a nicer, larger font because it is a TrueType font. But that's just the size of the font that we made it there. And I can show you that real quick just by changing from 80 to say 320 or something like that. Make it 4 times bigger. Oops, we got to recompile. Okay. Yeah, see, it's not pixelated because it's before I had a small image and I was stretching that small image. This one I told the font to be much bigger. So I'm going to change this back to 80. And let's see, this one should be not changing colors, but it should be text. creating text. Create text. Okay, so create text, and let's just walk through what we have here. We added the TrueType font header file, and then in the initializer, where is it? SDL initializer, we initialized that, and there's nothing exciting happening here. It's just wrapped in an if statement, and we're just doing the standard runtime error if it fails. And right at the top, we're closing it down, so we have that. And then we are creating we have a couple items in here. We have a font size. It's an int. We have a SDL color. We have a string for our text, what we're calling it text string. And we have a SDL rect. We're calling it text rect. And so we also have some pointers down here. We have a surface for our text surface. That's our initial way that we create the image. And then we're converting it to a texture. And that's just going to be called text. That's our target where we're going to. So we're initializing the font size to 80, the color to 255s. That gives us white, and it's not transparent. Our text that we're using, our string, is just SDL. Our text rect is going to be just zeros. I'm just zeroing it out. And we are initializing the text surface and the text to null pointers and making sure that we're using their deleters. Okay, so in the initializing, we're not doing anything new. But in load media, this is where we are creating we're resetting the font. We're creating our font, but we're resetting the pointer already exists. So we're creating our font, and the smart pointer also closes the font for us when it goes out of scope. And it's taking the path to the actual font and the size that we created. And then we're checking to make sure it was created. Then the text surface that we want to create is, we're resetting the smart pointer again for that one. And this is the TTF render text blend that gives us our nice looking font. And this is taking in the font that we just created. It's taking in the string that we initialized in the constructor. And this is also taking in the color that we initialized in the constructor. This is returning a surface. So we're checking to make sure that that surface was created and it's not a null pointer. Now, since we have the surface, we can just grab the width and the height from the surface and hold it into our rect that we already have. So we're doing that here. We're just setting our rect to setting the rect width to the surface width and the rect height to the surface height. And then we're converting that surface to a texture. So we're resetting that pointer with the SDL create texture from surface, and we need the render and we need the surface. And then we're making sure that that texture is in fact real. And we are making our error message for that, and that is an SDL error, it's correct. And the way that we draw it, it's back to front. So we got render, we got background, and then we have our text on top of it. And we are using the rect this time. And remember, when you pass the rect in, you're passing the pointer to the rect. So we're passing the pointer to the rect. And that is the destination rectangle. We're still using null pointer for the source. And that is everything. Okay, so I hope you enjoyed that one. That's going to be all for this video, and thanks for watching. Bye.